Okay. Everybody have these points on the graph paper? Cool. Okay, so for this problem, we're going to start with this problem and then kind of work backwards. It says the vertices of one of the diagonals of a square are located at these points. Enter values and select the phrase to describe the location of the other vertices of the square. Vertices are corners. Vertices, corners. So it gave us two of the corners making the diagonal of a square. So like if you were to connect these dots, and the more accurate your line, the easier this will be. And also the smaller your points, your coordinates, the more accurate your line will be. It's just there. So this is a diagonal of a square. And then we want to find the other 2 points that would make this a square. You can kind of eyeball it, guess, and check. There's also a method to this too, but I'll show you that in a second. Like if I put a point right there, then all the sides of a square should be the same. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that makes sense. And then 1, 2, 3, 4, 5. And so on. So this would make another diagonal, and then I can just connect this square, making this square as perfect as possible. You can use your ID as a straight edge, so wear your ID on test day. Okay, there is our square. It asks for these coordinates, so this would be at 2, 4, and then this coordinate is at -3, -1. So these would be 2 of my answers. Make a square. If you needed to like really figure this out, if it wasn't so easy to visually figure out, these are perpendicular bisectors. So they should have a 90-degree angle, meaning their slopes should be opposite each other or negative reciprocals. Also, if you look from the center of the square, it's like 2.5 diagonals in each direction. So you could kind of, it's like 2.5 diagonals, so you could hack it that way. The other way to do it is to find the midpoint of these 2 points, and that would be the middle of the square. So if you found the midpoint between -3, 4 and 2, -1, and just found the middle, like this would be -3 plus 2 divided by 2 would be -1/2, so -1/2, and then 4 plus -1 divided by 2, 3/2, so 1.5. So that would be the midpoint, and then you could use like opposite slope to figure that out. So there's different ways that you could do it. But yeah, that is the 2 points. So then we'd put these 2 points here, 2, 4, and -3, -1. And then because those points make the diagonals congruent and perpendicular. Congruent and perpendicular. They also bisect each other, but that's what's the answer in the answer choice. Okay, now we're going to go up and do number 5. It says Jalen constructs a circumscribed circle. What does that mean? Okay, so I'm going to review circumscribed versus inscribed. So circumscribed circle goes on the outside of the shape. So like for a triangle, this would be the circumscribed circle. Inscribed would be on the inside of the triangle, like this. Okay, so on this review sheet, it's, well, here it says select the line type Jalen uses to construct this circle. So I'm going to just kind of like sketch out the circumscribed circle like this. Cool. There's a circumscribed circle. Drag point X to the location of the center of the circumscribed circle. Okay, so we have to choose what kind of line type intersects at the center of the circumscribed circle. So we have this here. Perpendicular bisectors intersect at the circumcenter, or the center of the circumscribed circle. So if you had this memorized, you could easily say, okay, it's just perpendicular bisectors. You just click this. When you click it, and you'll see this tomorrow when we practice this on the computer, it like automatically makes your perpendicular bisectors for each line, which is nice, and puts the center. And then all you have to do is just drag this over here and put point X right on that point. So you just drag this right here and then you put X. Because perpendicular bisectors intersect at the circumcenter. Perpendicular bisectors intersect at circumcenter. Okay, the next one is much easier. This one's easy, it's just you have to have this memorized. So make sure to memorize this. Okay, then over here it says select the values to complete the trig ratio. For trig, SOHCAHTOA is what we need for that. Here it wants tan of theta. So you have theta right here. You have opposite, the hypotenuse, and the adjacent side from that theta. It wants specifically tan. So tan of theta is O over A, opposite over adjacent. So tan of theta is square root of 32 over 2. It doesn't want you to solve or anything, it's just asking for the ratio. So in these boxes, you just choose from the drop down square root of 32 over 2. So that one's actually pretty easy as long as you don't overthink it. Okay, next. This one right here, it shows a pre-image and the image of the circle shown. The center of circle G is at 0, 0, and the center of G prime is at 1, 1. So here for the original, I'm going to make it brown. This is the original. And then the new one is G prime, centered at 1, 1. So this is the new one. And then this is the original. Okay, it says the radius of G is 5 units. So the radius of this is 5. And the radius of G prime is 4 units. The sequence of transformations applied to circle G to create circle G prime is shown. So you're trying to map one onto the other. And it shows the transformation rules right here, and you're trying to figure out what C is and what D is. Well, the first one would be a dilation. So you're trying to figure out how much this is dilated to get this, and it's getting smaller. For the dilation, you need scale factor, and scale factor is always nu over the original. So nu over the original. And so the nu is 4. So we're just taking the radiuses. So you just take a dimension like radius, nu over the original, which is 5. So the scale factor is 4/5. This is 4/5 smaller. So you need to shrink this shape by a factor of 4/5. So you can take the coordinates and multiply them by 4/5. So that's what goes in here, 4/5. And so now once this circle is shrunk to have a radius of 4 essentially, then you need to move it on top of the other one, and you would move it, and I know this is small, to the right 1 up 1, so the center would be right here. So we're moving it, it's another color, so we're moving it right 1 up 1, right 1 up 1. So that would be x plus 1, y plus 1, which is here, x plus d, y plus d, so d would be 1. So not super difficult, but the format's kind of weird if you haven't seen it before. Okay, so the next one, the equation of a circle is shown. I told you that there would definitely be questions on equation of a circle. The equation of a circle that is most familiar to us is this one right here. So x minus h squared plus y minus k squared equals r squared. And from there, you can easily pull out the center and the radius. However, this one is not in that format yet, so you have to put it in that format. So this is what we have to do is follow these steps. We have to group it, like based on x's and y's. Then we complete the square, and I'll show you the steps too. And then the third is just like reformat it so that way we can pull out the x's and y's, or the like center and radius. Okay, so what I mean by group it is you have to put the x's with the x's and the y's with y's. They already kind of did that here. They don't always do that. So we have x squared plus 8x plus blank plus y squared minus 12y plus blank equals negative 27. So we group the x's with the x's, y's with the y's, and then left space to complete the square. Okay, so to complete the square, we're going to take this b term, divide it by 2, and then square it. So we're going to take this term right here, 8, divide it by 2 to get 4, and then square it to get, it comes out to 16. So I'll use a different color here, 16, and so that goes here. And then whatever we add on this side of the equation, we also have to add over here, add 16. And then we'll do the same with this negative 12. Divide by 2, and then square it to get 36. And whatever you add on this side of the equation, you have to add over here. Okay, the next step is I'm going to break this up into factors. So x and x here, and then two numbers that multiply to 16 and add to 8 are 4 and 4. 4 times 4 would be 16, 4 plus 4 is 8. So x plus 4, x plus 4. And then I'll do the same thing with the y's. Need two numbers that multiply to 36 and add to negative 12. So that would be negative 6 and negative 6 would multiply to 36. So minus 6, then equals, I'll add all this up. So 16 plus 36 minus 27 is 25. So it comes out to 25. And so then I have x plus 4 squared plus y minus 6 squared equals 25. And now I can pull out my center and radius. So remember, it's always opposite sign because the equation has a subtraction symbol here. So this would be negative 4, positive 6. And then the radius would be square root of 25, which is 5. And then I can plug this in. Okay, and then on the back, there's only a couple more. We're almost done. We did all the long ones. Okay, so on the back here, I'm going to zoom in because it's hard to see. Okay, Angela transforms a rectangle into rectangle JKLM. The corresponding sides of rectangle PQRS and JKLM are not congruent. Select all the transformations that Angela could have used. So transformations that would cause the sides not to be congruent would be like a dilation, because a dilation would make the shape like grow or shrink. Maybe a stretch. So like taking a shape like this and stretching it like this. The other thing I've seen some places is distortion. Distortion, I would see it as like maybe like this. I don't even know what a distortion would be, but it changes in shape and size. So those are the ones that would be not congruent. So that's what I'm looking for here. So here it just shows like the coordinates changing position. This would be a reflection over the line y equals x would give these coordinates. So a reflection, it would stay the same shape and size. For this one, multiplying by 3, so that would be a dilation. So that means they would be changing size, so those would be not congruent. This one would be a rotation of 90 degrees, so that would stay the same shape and size. Here, multiplying by 1.5, that would be a dilation, so it's getting bigger. So that is a correct answer here. And then this would just be a translation. It's changing location, but it's not changing size, so that's not what it's looking for. Okay, and then the next one, I'm going to zoom out. So for this one, we're going to first graph these points. It says point P is at negative 1, 4, lies on the line segment QR, and it gives us these points. So I'm going to start by graphing. Do it as accurate as possible so you can use the graph as a tool. Negative 1, 1, 2, 3, 4. By making my point really small, it'll make my line more accurate. So this will be point P. Q is at 1, 7, 1, 2, 3, 4, 5, 6, 7. Q and R, negative 9, negative 8. 1, 2, 3, 4. 2, 3, 6, 7, 8. By the way, the scratch paper they give you for testing, it is... Oh, thank you. The scratch paper they give you for testing is unlimited. So if you run out of graph paper, just ask for more. But nobody's going to like sit there and offer you more, but you can always have more scratch paper if you need to ask for more. There is my line. Okay, so now that I have the line drawn, I can make the points a little bit clearer and more prominent. Okay, so what I'm going to do is try to break this up into equal parts, and I look at this and it intersects exactly at an X and Y like axis there. Let's see. Okay, there. I broke it up into equal parts. I noticed that if you go up 3 over 2, each time it lands at exactly like an intersection of two lines. And then it breaks it up into 1, 2, 3, 4, 5 equal parts. Okay, and now I need to answer the questions. It says QP to PR is in what ratio? Well, QP is 1 part and PR is 4 parts. So that would be a 1 to 4 ratio. And then for QP to PR, let's see, QP right here is 1 part, and then QR is the whole thing, which would be 5 parts. So that would be a 1 to 5 ratio. And this order matters. You have to do QP, which was 1 part, R was 5. You break it up like that. And then last but not least, this one right here, a rectangle and a vertical line are shown. This is rotated around that axis. What shape would be created? It would be this one with the space because it would stay that distance away from the axis and create a hole in the middle. And it's smoothly rotating around. It doesn't like, I don't know, do the corner thing. It's just smooth. Okay, that is all. So to do, go ahead and turn in this packet and I'll quickly grade it and give it back to you so you can study. And then do homework number 7 on Schoology. It's already enabled and I will play the video to help you with some of the problems on the screen as you're doing it. And yeah, any questions? My touch screen stopped working.